KNN, KNN classifiers. So yesterday we talked about the linear regression and the logistic regression, how it really works. Uh, Coming to logistic regression, linear regression, we use the outcomes, y value should be in the numerical. In the logistic regression, it will become in the binary format 0, 1, 2. And now today we are talking about the KNN classifiers, 10.ipynb. So in the code, what we have to do first, print of hi. Let me click on shift enter. Yeah, that's good. And now same from sklearn dot datasets import load underscore arrays. So it's a pre-built datasets. And now what we have to do, so we can take from sklearn dot neighbors import k neighbor classifiers, k neighbor classifiers. And then we need to take from sklearn dot model selection import train test split. And then what else we need? We need the standard scalar. Why? From sklearn dot pre-processing import standard scalar. And now we're done with this. As usual, we will be doing with the df equals to uh, load underscore iris. Click on shift enter, and then x equals to df dot data, and then y equals to df dot target. So if we click on shift enter, the x value should be in the outcomes like 5.1, 3.5, 1.4, 0.2. These are see very far. While we are plotting a graph, these values are like getting a bigger graphs. So we need to normalize these values. For this, we have a normalization called a standard scalar. It will reduce the dimensions from four dimensions to like a two-dimensional array like that. So we can change it's a four-dimensional, but it will reduce the numerical value of 5.1 to which was greater than mean of zero and the standard deviation of one. That's what. And now what we have to do is we have to take scalar equals to standard scalar, and now x equals to no. Before that, we need to take x train, y train. That's what we have to split the data. Click on code. That's what we have to take. X train, comma, x test, comma, y train, comma, y test equals to train test split of x, comma, y, comma, test underscore size equals to 0.2, comma, random underscore state equals to 42, and then stratify equals to y. So we're done with this. And now, if you want to check, then we need to see. We're done with the x train, x test, y test, all the things. And now we need to transform these x train values. If I take x train, so what will be the values? Like this I'm getting. 5.1, 3.5. These are the things I'm getting. So we need to normalize these values. So x underscore train equals to, so we need to take the bigger x. That's good. Yeah. X underscore train. So we are updating this value with the scalar dot scalar dot fit underscore transform of what we had to give x underscore train. So if I click on shift enter, see if I ask the x underscore train, see what the values I will be getting. Before I will be getting the bigger values like 4.4 all the things, and now we are reduced the dimensions between 0 to 1. So because see we need to plot the graphs very beautifully, and it don't need to get the higher values, and it will be difficult while training a model. That's what we need to do it like this. And now we need to get x underscore test equals to scalar dot transform of x underscore test. And why we are not only doing before this, before x, if we are give x only, then it will be done in a single instance, right? But we never have to give like that, because it will be the fit underscore transform will be taking the mean and average all the things, and there is no need of taking the second time. That's what we need to after the split only we need to do with the scalar. So one guy asked me the doubt in the previous class. That's what I'm saying in this class. And now let me run all now. 1 second. So now it's good. Because if I done another time, then it will be transforming another time. That's what I did the run all. That's good now. And now what we have to do, the y value should be 0, 0, 0, 1, all the things. So the thing I have to do is we done with all the things. So model equals to the k neighbor classifiers of, we have to take an n underscore neighbors equals to 3 or 5. Because why we are giving n underscore neighbors equals to 3 means we are taking the number of majority of votes. And see, in the linear regression, it will be taken in the x and y values are the independent and dependent values. And in the logistic regression, it will be get with the numerical binary classification. But in the KNN classifiers, it will be taking the majority of votes, which is Tulsa, which is Virginica, which is Versicolor, like that. So we can take the nearest of three values or nearest of five values. So we can give any one of the random value and then n underscore neighbors. So in our homes, the neighbors should be say we are good. That's it, right? Same like that. In n underscore neighbors will be given the values which are Tulsa, Versicolor, Virginica. And then this model dot fit of x underscore train, comma, y underscore train. So if I get any error, we can able to check. Okay. And then y underscore train equals to same. All the things are almost similar, because in the machine learning, in the deep learning, artificial neural networks, like almost similar. Because every time we need to give the model and the Y prediction, all the things. So these are the common steps. Predict of we have to give x underscore test. So let me done with this. And now we don't need to check skeleton dot matrix all the things, but we can check one time. Matrix import mean square error. Where is that? Look on the top. Accuracy score and classification report, and you can take confusion matrix. So all the things. So we can take the classification report of CL equals to classification report of Y squared, comma, Y underscore test. So the classification report, what it will be printed, it will be given the precision, recall, F1 score, support, all the things, but we had to write in print statement. Okay, then it will be good. So now it's good. We are getting the precision, like for the Setosa, Versicolor, and Virginica, and we are getting the recall score, F1 score, and the support, all the things. And now see, we can take the accuracy, the macro average, the weighted average, all the things. And I'll be given brief introduction about this in the PDF. I will share you the PDF by end of the day. And now we have to take in the classification report, and also we can take about the confusion matrix also. Confusion matrix equals to confusion matrix of, we in this we are getting true positive values, true negative values, false positive values, and false negative values. So how we can check why prediction and why test, either I will get the confusion matrix or not, I don't know. We can see. And then prime of CM confusion matrix. So in this we are getting the confusion matrix. So in this we are getting the true positive, true negative, false positive, and false negative. So we are getting in the matrix format. So I'll be given all the every document in detail. And then what we have to do is we are getting the confusion matrix, the classification report, and we can do the accuracy score. I think either we can check the accuracy score we are getting or not. Current of AC. So we are getting the accuracy score of 93%. So we are getting almost good. We can check about the mean square also, but we don't need the much. We are almost done for more than enough. But we have to know everything. And then we can take the as it is, the values should be, we can take A equals to uh, um, as NP, and then A equals to NP dot array of, we can take the new values like but we don't have to take the normalized values, we have to take the real values only. And then we need to transform again and again we need to transform. And then A equals to scalar dot transform of A. Because why we need to change normalize it, because it will understanding the normalizing values only. That's what in the click enable classifiers it will be, see it will like in our homes, if our home is very lone and our homes neighbors are very far, then it is not good. They can't understand our what we are doing. If we are neighbors are very close to us, then they know like all the things. So saying like that, we are normalizing the values. That's what it will be taking the maximum votes which are nearest to the that particular neighbors. That's what we are normalizing the values, and then we have to make the prediction. Uh, Prediction equals to model dot. So once so we are getting as the model dot predict of A. That's what prediction of zero. We are getting the zero means sedosa. That's what we had to write. Result equals to. Can anybody say what I have to write at the ending? Lakshmi.
The result equals to prediction.
Rup,
Then the result equal to prediction are brackets.
we need to get the sedosa name right. So null title issue, and then tf dot uh, target underscore names of prediction of 0. Control C, Control V. So we had to write and then result. We need to get the Setosa. If I did it in the print, we had to write Control V, print of Setosa. Uh, and that's it. We're done with the logistic regression very beautifully. And now, Lakshmi, you can stop the screen share